YC Mathematics and Physics, University Calculus, Lesson 19, Definition of Derivative, Part 3. We start with an example. Y equals f of x equals c over x squared. C over x squared. Here, the c, of course, is a constant. So we use the definition of derivative. So the definition says y prime is equal to f of x plus h minus f of x divided by h, and takes the limit h goes to 0. This is the definition. As before, we have examples before part 3. So we have part 1, part 2, we have examples. Now we use the same definition, use this formula to do this example. So what is our y prime? Y prime is the limit. H goes to 0. This x is replaced by x plus h. So I have c over x plus h squared minus the function itself. And divide by h. So continue. Limit okay. Let's do the common denominator in the numerator. So common denominator. Then I have c x squared minus c x plus h squared divided by h. Limit h goes to 0. So we need to expand the numerator. Look, this is the denominator, and this is also the denominator. If you simplify this, this will go to the bottom. So expand the numerator. Cx squared minus cx squared minus 2c hx minus c h squared. At the bottom, I have h. This is the denominator, but this is also the denominator. If you simplify a fraction within another fraction, so this is also the denominator. Okay, continue. Cx squared minus cx squared is gone. So what is left is this one and this one. and the denominator, okay? Now, you see that the numerator has h here and also h squared here. So you have a common factor h. So factor the common h. Factor the h. And what is left is minus 2cx and minus ch x plus h square x square. Limit h goes to 0. Look, this h and this h can be cancelled. So what is left is this and that. H is gone here. Now, we do the limit. The limit is h goes to 0. So, h goes to 0. This is gone, so I have negative 2cx. In the denominator, h becomes 0, so x squared times x squared. X squared times x squared is x to the power 4. Then this x and this x to the power 4 can be cancelled. So finally I have negative 2c x to the power 3. So this is my answer. Let's have a second example. Okay. Okay. The second example. Y of course can be written as f of x is equal to 2 divided by x plus 1. And we want to find the derivative. And we use the definition of derivative. Okay, I'm not going to repeat the formula for the derivative. Let's just go ahead. Y prime is limit h goes to 0 and I need f x plus h. So I have x becomes x plus h. Then subtract the original function. The denominator is just h. So let's go on. Just like the example before this, we do common denominator. The common denominator is the product of this denominator and this denominator. Okay, 2. Divide by h. Okay. Let's simplify the numerator. (2x plus 2 minus 2x minus 2h minus 2. X plus h plus 1, x plus 1, and h here. Okay, go on. Two x minus 2x is gone. Plus 2 minus 2 is gone. So what I'm left is just negative 2h. Then just copy this denominator. Okay, carry on. I have, oh, I forgot there is an h here. I have a fraction here. This fraction is within another fraction, so I simplify this. That is when you simplify a fraction within another fraction. Now you see this h and this h cancel. So I have only minus 2 on the top, and this h is gone. Oh, sorry, this is not 2. This is x. I made a mistake. This is x, not 2. Sorry. And this is x. Just a mistake. Okay. This is x. X plus h plus 1. X plus 1. Now the next step is to let h goes to 0. Take the limit. H goes to 0. So negative 2 here. Look, h goes to 0. So I have x plus 1. I have another x plus 1. So finally, negative, I put the negative in front, and this 2, and x plus 1 squared. And this is my final answer. So I have 2 examples. These 2 examples are when the given function is a fraction. And we see that we need to do common denominators. Other than that, this example is very, very similar to the examples before our today's lesson. So you are ready to do some practice problems. So I give you a practice problem on the next page. Let's see now. So this is only from problem 1 to problem 7, and I have altogether 11 problems. Okay. Maybe I can do this. You can copy this down. You can copy this down. Let me do that. Let me see now. So maybe I can do this. Then you have everything there. Then you have the whole page from number 1 to number 11. But this is rotated. Okay. I don't know whether you can copy this down or not. You should be able to copy this down, right? So all these questions are fractions. So you do according to the formula, the definition of derivatives. And you should be able to get the result. I'm not giving you the result. I'm not giving you the answer. But I'm sure it's not difficult. But just practice. I suggest you practice all the problems. Yeah. Don't just do only a few and you think that, oh, I can do it, so I don't need to do the rest. Don't think that way. If you want to be very good at this kind of thing, you need to do as many practice problems as possible. Good. So this is today's lesson. And the next lesson will be something else. It's no more definition of derivative. It's something else. So thank you for watching, and I'll see you next lesson. Goodbye.